Today we want to graph some sinusoidal functions that we want to come up with graphs of some sine waves. We're also going to be doing this in radians. So we've done these graphs before in degrees. We want to do them in radians. So instead of going from 0 to 360 by 90, I'm going to go from 0 to 2 pi by pi over 2. That's just the radian version of what we had before. Pi over 2 radians is 90 degrees. So instead of 0, 90, 180, 270, 360, I go 0, 1 pi over 2, 2 pi over 3, 2, 3 pi over 2, and 4 pi over 2. We want to draw nice graphs of sine and cosine. So I broke each quadrant into threes. So I took my 90 degrees and split it up 30, 60, and 90. Oh, excuse me, this is radians. I took my pi over 2 and I broke it up into a pi over 6, a pi over, and a pi over 3. That sounds terrible. I took my 3 pi over 6 and wrote 1 pi over 6 and 2 pi over 6. So this first mark is at pi over 6. This second mark is at 2 pi over 6. So this pi over 2, or this third mark is at 3 pi over 6. The reason that we want to do that is because pi over 6 is where sine gets a half. So that's why I was able to mark this point here halfway up to the 1, because the sine of pi over 6 is equal to 1/2. So then I just found my pi over 6 reference angle in each of the 4 quadrants. So here's pi over 6 in the second quadrant. Here's pi over 6 in the third quadrant. Here's pi over 6 in the fourth quadrant. And that's where I put the 1/2 and the negative 1/2. Because we're remembering, we know our values. At this point, we know our values. That was a risky erase. There's a chance of a lot of collateral there. So that helps us get the right bend. So we don't just draw lines, go up, down, then up again. That helps us get the right bend. Over on the cosine graph, here's our cosine graph. We know that cosine of 60 is equal to 1/2. So I locate my 1/2s, my 1/2 and my negative 1/2 at the 60-degree reference angles in each quadrant. So here's 60 degrees. So the one I got here is because we know that cosine of pi over 3 is equal to 1/2. Then here's 60 degrees in quadrant 2. Here's 60 degrees in quadrant 3. And here's 60 degrees in quadrant 4. That identifying those points helps us draw nice bends in our graphs. Here's what we want to identify. We want to name some parts. Some official names for these parts, and then some local names for these parts. These are what we're going to call them locally. And then we'll have other names that will be the common names for all these parts. So remember that sine is just going to go up and then down and then 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 up and then down, up, down, and then up and then down. And it's going to do that forever. The same thing with cosine. So I want to identify 3 locations vertically on this graph: the top, the middle, and the bottom. And it is unsurprising where these places are. Here's the top. Here's the middle. And here's the bottom. Note that for both graphs, the top is at 1. The middle is at 0, and the bottom is at -1. So the way I'm going to think about this is I'm going to say the bottom is normally -1. The top is normally +1. And the mid will normally be 0. So the top, mid, and bottom are vertical locations on our graph. These are leachisms for these. This is like calling things cookies or biscuits. Locally, we'll be talking about the same thing using a different word. I'll talk about the top, the middle, and the bottom. One thing that we all agree on is that the distance from the middle to the top will be the same as the distance from the middle to the bottom, and we're going to call that the amplitude. The amplitude is going to be the distance from the middle to the top or from the middle to the bottom. For graphs of sine and cosine, those two distances will be the same. That's why we can get away with calling it the middle. We built these functions by tracking the x and y coordinates going around the unit circle. That's why after one full circle, or 2 pi radians, we have gone through one cycle or one period of function. So we want to talk about the period of these functions. And I refer to the period, I say the period is the distance. The period is the distance between what I refer to as corresponding points. Our period is normally 2 pi. Our amplitude is normally 1. In all these, I'm referring to something called normally. What's normally going to happen? It's like our default setting. I should switch my language to say the default. But at this point in my life, I've been saying normally for so long, I don't think I can switch. So I'm going to normalize this defect for you. So normally means y equals 1 times the sine of 1x. or y equals 1 times the cosine of 1x. I mean coefficients of 1. Both in front of the trig function sine or cosine and in front of the x. That's what I mean by normally. That's our default setting. 1 sine of 1x, 1 cosine of 1x. Normally is just our default setting. What do I mean by these corresponding points? So these graphs, they have a middle, a top, a middle, and a bottom, and a middle, and a top. Missed. There are 4 different corresponding points that I like to identify. I like to identify the top, I like to identify points that are the bottom, so when we talk about the period of one of these sinusoidal graph functions, we're talking about the distance from a top to a top, or from a bottom to a bottom. Those are corresponding points. These are corresponding tops, these are corresponding bottoms. Notice that I've got 4 mids running around here. There are 2 different types of middles. One is a middle going up, and the other is a middle going down. So I've got a top and a bottom and 2 kinds of middles. There's a middle going up and a middle going down. These are corresponding points. There's a middle going up and a middle going down. So the distance between 2 middles going up is the period. We can see that in our graph of sine from 0 to 2 pi. 0 is a mid going up, 2 pi is a mid going up. Pi is a mid going down, so at 3 pi, there'll be a mid going down. So those are the 4 kinds of corresponding points. Top, mid going up, mid going down, bottom. And they always follow the same cycle. Mid going up, top, mid going down, bottom, mid going up, top, mid going down, bottom, mid going up, top, mid going down, bottom, mid going up, top, mid going down, bottom. All right, now mid going up top, mid going down bottom. Okay, now I'm done. Mid going up top, mid going down bottom. Mid going up, now I'm done. Top, mid going down bottom. There's no end, so I can't just like stop when it ends. What we want to do is figure out what happens if we change the default settings. If I change the coefficients, what does that do to our top, the middle, and the bottom? Or what does that do to the period? All right, let's take a break. We'll come back and we'll ask this question.